just uploaded. I should say first and foremost that these materials are basically just completely stolen. So I was thinking about how I wanted to do this workshop, and I decided to watch RStudio's Intro to Shiny tutorial series. And it's a 3-part video series, and I watched them all, and I was like, wow, that pretty much covered everything that I would have wanted to cover. They have really great slides and code to go along with all of that. So I was like, no need to reinvent the wheel. I'm just going to steal it. And so I took those 3 parts and I created one set of slides and obviously one workshop. So it's an edited version of that, but all those materials are there. If you want to rewatch, who knows how our audio will go today. If you want to rewatch very similar material, it's all there along with the code and the slides and everything. So it's just sort of a thank you to RStudio for making this, and also just a disclaimer. But I still think it's good for us to have this workshop and go through it together. And, we can ask questions, which you can't really do with a YouTube video, at least not with immediate response. There's always the comment section. But yeah, it's also just good, to work with other people and see it live. So. Okay, so like I said, so these 3 PDFs, the how to start, those are the original slides that RStudio made, particularly Garrett Grolman was the guy who gave the talks. So I took those and I created this one condensed version that I'm going to be working off of, which is shorter. The Shiny Basics is just some of my notes in R, and then the code you'll be going into a lot to get these kind of teaching Shiny apps that we'll be running and looking at how they work. Okay, so you should have that. So thankfully, the only package you'll need to download and have installed is Shiny. So hopefully no one has any issues installing that. Fingers crossed. And so before I start going into, so this is really like nuts and bolts of Shiny, how it works, and the really important functions that you'll want to know and be using a lot. I think we're going to have less time to talk about all the customization features, and there are many. But I think the more important thing, if you're just starting out, is to understand the architecture of the app itself. And then you can make it pretty. You can make it as pretty as you want to later on your own. Okay, so I asked who's seen a Shiny app before. Not surprisingly, it seemed like everyone had seen one. But I still want to walk through a couple of them, just if you haven't looked at them in a while. So RStudio has, I can make this even bigger. RStudio has a catalog of different uses of Shiny. I looked through a bunch of those. I actually wasn't super inspired by the ones that were there. I also asked around, so thanks to Ryan and Rich who aren't here, but I asked them for some suggestions of apps that they liked, and they provided some. So I'll start with one of the basic RStudio ones. And the thing about opening these will close, like if you just leave them open on a browser, they'll close after a while, because just to limit the amount of active users. So I'll be opening them like as we speak. Okay, so here's a basic Shiny app with basic data that you've probably seen before. But it has some discernible features, right? It has adjustable inputs that the user can interact with. So here's the X variable, the Y variable, and the number of clusters it's going to fit. It's going to use k-means to cluster this data. And then I can go in and change the X variable. As soon as I change it, the plot updates. An error occurs. It doesn't really want to use species as a Y variable. Sure. Maybe I need to change the number of clusters. No, it just doesn't like that. That's fine. I keep going, etc. So you can play with it like that, right? Very clear input-output structure. All the output is in this plot here. For those of you, and I recognize a couple people who were at the interactive visualization workshop a couple weeks ago, a big difference here is that I haven't given this app, I haven't given it all the possible plots and clusterings that a user might want to see, right? It's creating these dynamically. And in this case, for me to give it all these possible options, that would be a lot of information to throw at the browser. So it sort of makes sense that I just give it the structure and then it creates them on the fly, right? But to do that, and this is the first slide we'll see, but to do that, we need to have a server, right? Or we need to have some computer that's actually running R that it can ask for all this information. Okay, so that was a simple app. A slightly more complicated one. I think I liked this one. This is one of Rich's. Yeah, okay. So it's a similar idea, right? I have these inputs that the user controls. I have one output graphic here that depends on these inputs, and I can update some, you can see. Every time I click, I get a new image, and turn off the shallow ones, and you can really see a difference. And then he also, you'll notice, has some tabs. So I can look at data in a tabular form. I can see more about the application. I think you can download the data somewhere. Yeah, so similar idea. I have a basic input set, output graphic, but now I have some tabs and some more nice features. And then one more complicated one from, I believe this is from Ryan. Worked yesterday. What happened? Yeah. Maybe I used all their user time yesterday. There we go. Okay. So now we again have a bunch of tabs. This basically looks like a website, right? And I actually have heard of people building like their academic website in Shiny. Not necessarily recommended. It depends on what you want to do, but it certainly works and it looks professional enough. So, so here we see not only like we have tabs, we have inputs. They don't really mean anything particularly to me, but some wells, I guess. And then what we can also do, which I won't have time to cover this particularly today, is you see actually linking between what's going on in this graphic here with the wells and then these plots here. So no longer just drop down or text inputs, but we can actually use the data in one plot or graphic to control what's happening in the others. So that's sort of a long-term goal, something that might be useful to you. Again, we won't have time to get quite to there, but okay. So there's a range of things you can do at different levels of complexity. But today we'll start with the basics. I think that's okay. All right, so here's the disclaimer from the material that I stole. Right, use it at your own risk. And we talked about the showcase, it's there, so you can go and explore a lot more examples. Okay, but let's dive into the architecture. Maybe this can be bigger. 1 second here. Then I'm going to have to keep going out of it to go back to art. So I think I'm going to leave it. Okay, I'll try it. At least for now, we don't need code. So okay. Okay, so we mentioned, right, unlike an interactive visualization that you make in Plotly, where you come out with some HTML that you can just move around as you see fit, right? A Shiny app needs to have some computer running R that's actually powering it and doing the data operations. So when you just run a Shiny app on your computer is that computer, right? You can also have it point to a server, right? And then it's no longer taking over your own computer. It's some external server, possibly run by RStudio or someone else that's going to power your app. Okay, I lied. Actually, we are going to go straight into some code. So in the folder, that you downloaded, there's a code file. There's this code file, or folder, sorry. And in the code folder, the first one you want to open is 01 template. And ideally, you're opening in RStudio so that we're all looking at the same thing. So you open that one, and you should see something like this. Okay? Is everyone there? Great. Okay. So this is a Shiny app, right? notice, so I have to load the Shiny package. So hopefully everyone already has that installed. The first element is a UI function. Currently, it's just fluid page. The second is server, which is a function of some input and some output that we haven't described yet. And then our app, which needs the UI and the server elements to run. Okay, so click, just if you have it open, click Run App. So now you've just built a Shiny app, and there's nothing in it, but it's there, and you can see it. Okay. I think you could probably even have an even shorter Shiny app, but let's go back now. And let's add in fluid page, let's just add some text and then run again. So now I actually have something in my app. So now you've created an app with something in it. It doesn't really do anything, but it's there. Okay. So if you remember, we saw this app that did k-means clustering on the iris data, right? So again, we had these inputs that we controlled, X variable, Y variable, cluster count in this case, and then this output plot, right? Output plot. So that stuff, right? That input and output, where we just put hello world, right? More generally, we can put inputs like drop-down menus, and we can put outputs like plots, right? That's all going to go in our UI. So inputs, right? So we've seen visually some of the things that we have available, like drop-downs. Another common one to use is a slider, right? So slider input is a function. I can just go in here, type it in. Right, so it's a function in Shiny, in the Shiny package, that constructs a slider widget to select a numeric value from a range. So it'll just call this function slider input. Why is that happening if I'm on the hard line? That shouldn't happen. Okay. Is the Zoom still working? Okay. Slider input, I give it an input ID, which is num. I give it a label, which is choose a number, and I give it values. So it's pretty intuitive. Maybe this part is not quite obvious, but the input ID is what I'll refer to it, how I'll refer to it internally when I'm building my app, versus the label is what will appear to the user. And then it's a slider, so I need a minimum value, a maximum value, and then this is a default value. And if you actually just, let me see if this works. Say again?
Input ID would be equivalent to
basically, yeah. It's going to be a variable in a list. So it's the name of the thing in a list. Yeah. If I just write slider input in R, let's see what happens with empty brackets. No value. Let's try adding min 1, 2. No, we still need to add more. Let's add test and put ID. It doesn't want to do it. All right, well, we'll see what another one. I wanted to be able to actually print out this this HTML code. So basically, this function with these arguments is equivalent when your browser sees it. It sees this. We'll see it. We'll see an example of that where it's easy to show. Okay, so we can manipulate that simple app that we just saw. Now we're going to actually, instead of just putting raw text in fluid page, we can actually put some inputs. So we'll put that slider input. And if we add that, then a slider comes up. And here's just a range of different other things that you can add. You're not going to want to memorize them, but eventually you'll start to remember which ones you want. And it's always good to just kind of guess, right? and help. Like if you know you want a checkbox, if you search for checkbox, you'll probably find it. The names are pretty intuitive. So sliders, select boxes. I think I've used most of these. I don't think I've ever used a password input, but the rest are pretty helpful. So again, I think the most non-obvious thing is that we need to have a variable name for the input list, and it'll be clear what that means in a second, which is the input ID, and also the label that the user sees. And then whatever arguments this input takes. All right, so then we'll just see a simple output, and then we'll go back to the code. So here our output was a plot. There's a lot of different kinds of outputs that we'll have, and we'll wrap them in these output functions. So plot output is going to be plot, camel case, so capital O output, right? And again, if you guess, there's a pretty good chance you'll get the name right. So like if I want an image in my output, I need to put it in image output, data table output, text output. So we want to show this output, right, if it's a plot. So we're still going to put it in our UI, but now it's going to be, the thing we're putting is going to be wrapped in plot output. And I can probably just turn my Wi-Fi off for now. Okay. Oh no, I can't. I'm on Zoom. What am I doing?
It's okay, Jane. I'm just doing the calls before you don't worry about
Okay.
it.
Okay. Right, okay, so I know I wanted to display plot output. I haven't explained why this word hist is going to be meaningful to this app quite yet. But so far we can just see that our output function is going to take some character argument in this case. But it remains to be seen what this hist actually is. Okay. But in terms of the user interface, right, we're going to put in the slider input, and then we're going to put the plot. And if we don't give it any specifications about how to arrange these things, it will probably just create new rows for each item, unless it runs out of room. Let's see, we can. Right, so like I said, we haven't actually given hist any value yet. So for now, if we tried to build this app, it's probably not going to work. And let's actually just, oh, okay. So for now, we'll just see this as a placeholder. The way that RStudio writes their materials, they kind of recap at very frequent points. We maybe don't need to go through this since we're going through all this at once, but I'll just leave them there. Sometimes they'll probably be more helpful. Okay. So we talked about the UI. We put some stuff in it, right? We put a slider input and a plot. Now we'll talk about the server function, which was the other main component of the app that we first saw. That's where we're going to actually give that hist a meaning. Okay. So the server function in general is a function of some input and some output. We haven't defined what this output is yet. But notice that this output list, so these input and output lists are going to be key features for us. So this thing that we're going to create called hist, we're going to add it to an output list, output $hist. And once we do that, then when we call plot output of now as a character hist, it will know that we mean the item called hist in the output list. Okay, so if we want the UI to look at things from our server function, output from our server function, we're implicitly, or here explicitly, adding them to the output list with certain names. We still haven't actually defined what this thing is, right? So what we're going to do is make it a plot. So This is the first time we've seen render, okay? So unlike just a regular, calling something with a render function, so there's a whole bunch of different render functions, render plot, render image. Calling something with a render function is different than just saying plot this stuff, right? And we'll see more of that. But for now, just notice we're going to put this plot that we're going to make in render plot, which will then send back to the output list, which will then get called by the UI. And like I said, there's a bunch of different render, some very similar to what you saw before, the different output functions. There's a bunch of different render functions for different types of things that you'd want to render. Okay. All right, now we're finally actually going to define what this hist thing is. So we're just going to make it a histogram. So it's basic our plotting function of a random normal data that we sample. So we're going to sample 100 draws from a standard random normal distribution, and that's what we're going to plot, okay? So now we have in these curly brackets, so this whole expression, we can make this as short or as long as we want, but in these curly brackets, an expression that will evaluate, send as the output of render plot into our output list under the name hist. And we can do more than just put in the data, right? We can have a title. Whatever is in these curly brackets is going to be the whole expression that's evaluated by render plot. Notice here in this slide, we're now actually not only going to sample 100 draws from a normal distribution, we can actually specify the number of draws using something that we put into the input. So just like I said, there's this important output list that we'll add to and can be recognized by our UI. There's also an input list. So implicitly, if you remember, we created a slider and we gave it the input ID num. That means that when we're in the server function, if we call something input $num, it will be that slider. So again, there's default input output list that we use to communicate. Okay, so yes, it's just going back to saying when I gave it that ID num, it knew, okay, add this thing called num to the input list. And every time I change the slider, the value associated with the input $num will change. Okay, so let's see, let's actually go ahead right now and open in the code folder, to hist app.r. Okay, you should see something like this. So far we've really just talked about the structure of the UI and the server and how they the default communication between them. But we haven't actually said when, and we also said that when we update the slider that this value updates. But we haven't talked about when the whole code chunk that's evaluated in render plot, when that updates, right? And so default reactivity in RStudio, in Shiny, dictates how this code responds to changes in our input, okay? So this is this whole idea of a reactivity chain that's pretty key to Shiny architecture. So this is the first we'll see of it, and we'll come back to it again in more detail. But basically, things that I put into the input list are part of the reactivity chain. If I evaluate them in any of the render functions, that continues the chain. So that means that anytime I change something in that input slider, this code knows it has to update, and the output will automatically update. And that can be a good thing, or it can be annoying. And we'll see an example later of where it's annoying, and we might want to kind of control that so it doesn't just automatically update every time. But for now, it's basically like my left arm, my right arm, whenever anyone's pulling my left arm, my right arm is moving with it, okay? And so that's just what they're breaking down here, Reactivity 101. I put in something from the input list into a render function, send it to my output list. Everything's part of this reactive chain. So graphically, what that looks like, right, is there's this link between input and output. So let's go ahead. And so you have this app open. Let's actually run it. You should see something like this. And let's just visually see what this is all equating to. Make it smaller. Oops. Okay. The bottom, very bottom of mine is cut off, but that doesn't matter. Okay, I changed the input slider to, I don't even have to take my hand off the cursor, and it already updates. As soon as it hits another location, it's updating. And if I go down and make this very small, right now I'm just, it's a histogram of 5 values. It's not particularly valuable. I go up to the top, I now have a histogram of 100 values. I start to see a normal distribution. Okay, but again, there's nothing, as soon as I change this, the plot changes, they're completely linked and reactive. Any questions about this so far? Okay, onward. Close this. And okay. So again, like I said, there's a lot of recaps in here. I didn't take them out. They're useful. I found them useful when I was first watching this. Less so when I'm here kind of going through it all live. But just really key, right? The input and the output lists exist for you to use. They're default. And we'll use render functions to display this reactive output. Yeah. Okay. So sharing your app. So this first, so we're almost done with the first part of this actually. The first part's kind of an overview. So they're jumping straight to the sharing your app. I think we'll come back to that. I'll move on to more architecture. And then once we have, you know, some apps that are maybe more worthy of sharing, we'll talk about how to do that. I'm going to go over 2 ways to share it that are both very simple, and there are more complicated ways. But like I said, we'll skip it for now. And go more into reactivity. But I promise we'll come back to that because that's very important. Okay, so I've so far given you just one family of example of reactive functions, which is the render functions, which render different kinds of images. But now we're going to go over other types of reactive functions that continue that reactivity chain and give us more control over how this reactivity is occurring. All right, so we saw our slider, right? And we used the input of the slider to create a plot. If I tried to put this input $num, that value from the slider, into just regular R code, it would break that reactive chain. If I tried to then send that to like the output list, it wouldn't work. It wouldn't create this dynamically updating plot. So I need functions that continue the reactive chain to get this input-output response. Okay, so this is the app you have open now, right? And like I said, if you tried to just put, just create a histogram and send that to your output list without wrapping it in that render plot function, you'll get an error. Okay, so delving deeper into what reactivity is actually doing, every single time an input value updates, any code in my server function that sees that input will be notified that, okay, now I'm out of date. So I need to know what the new value is here, and I need to rerun this code. And it doesn't matter. So let's see this example here. It doesn't matter if there could be multiple input values here, but if they're all wrapped in this one expression, if any of them update, the whole code block is going to rerun. Okay. This is sort of just getting at, right? Anything in that, by default, with the render function, anything in the code block updating will cause the whole block to rerun. Yeah.
Do you need to rerun in the Shiny server? Or can it be like, for example, you change something, some parameter, and it sends that code back to your, to somewhere that you run the code, and then sends back to the Shiny server the result, so that you can use as the input for the browser.
I'm not sure if I understand the question. So,
because you was talking about simple stuff.
Yeah.
But if it is something kind of heavy, would that have to be run in the Shiny server?
So this code here, whatever's here, for example, yeah, that's gonna all get rerun. So there are gonna be ways to kind of control what causes that all to get rerun, because maybe that's like, slow, intensive code, right? So it doesn't have to be this way. Again, we'll get to that, right? It doesn't have to be that every single time I update any input, all of my code or large chunks have to run completely. We'll split it out, but so far with what we've seen, that's going to be the case. Yeah. Okay. So again, I mentioned this before, but right, any of these values in here, in this code chunk, getting updated will cause this whole chunk to rerun. All right, so let's see how this works and why it might be good or bad. Let's open in the code folder the 012 inputs app and run it. See something like this. All right, so again, if I update the slider, the plot updates. If I start updating this title, every single time I'm typing a letter, it senses I've changed the input and it wants to update the whole plot, which is probably not exactly what I want, right? And let's just take a look at what the app actually looks like, right? So especially for people who've never seen these apps before, just a quick kind of one-to-one on the structure versus the code, right? So I have my slider input again. We talked about that one, which goes here. Now I also, after slider input, I have a comma, and then I have another thing, right? So like I said before, default is it's just going to put it on a new row. So here, the second row of my user interface of my output has this text input with input ID title. So that's how it's going to appear in the input list. It's going to be input $title. And then the label, write a title, is what the user sees. And then unlike the slider input where the default value is a number, the default value here is going to be the default title value that we'll start with. And that's all we give it. And then we still have our plot output, which is hist from the output list. And that's going to appear here. And in our server function, right, where the plot actually gets made, it takes, so we're going to use render plot, right, so that we have a reactive plot in our output. We're going to store it in the output list as the value hist, which is why this plot output hist in quotes actually works. And what we're going to make is a histogram of random normal draws of input $num. So we're going to use, in this case, 79 draws. And then we also gave the plot a main argument, right? So the main argument comes from its input $title. So it's coming from our text input, whatever, we started with a default value, but whatever we put in the text input is going to actually be the thing that input $title equals, right? So for each kind of those different inputs, like a slider input, a text input, right? The output of that, like what actually is in input $title is specific to that input object. Slider, it's a number, text, it's text, etc. And then we run it using the Shiny app function, or we just click the run app button. Okay, so in terms of reactivity, right, that means that, again, looking at this code chunk, I have in creating the histogram, I use both input $num and input $title. So that means that when either of those things updates, the plot will update. Right? And so say I update the title, right? Then this code chunk knows it's out of date, and it will go back and take the most recent value from both of these input arguments, even though only this one was the one that notified it it's out of date. Because both of these input arguments are in the code chunk, it goes back and looks at both of them. All right, so we saw kind of why that might not be ideal, right? It's too many updates. Thankfully, this code is very quick, but it won't always be, right? So we can change that. All right, so let's open the next little app they gave us, which is O2 inputs. And let's look at this. Okay. So we're going to take what we did before. We're actually going to also add a summary values down here, which are a little small right now. But if you just click this app, reload app, you can actually see it. Oh, I need the next one. Sorry. Sorry. There's two outputs, and there. That's what I want, right? Two inputs. Why isn't that? Hold on a second. Oh, I need O2. Okay. I don't have it open. So open code, O2 outputs. It's weird. Oh, that's my typo. Hold on a second here. Okay, outputs. There we go. Okay. So O2, the O2 outputs file is what we should have open. Sorry about that. Okay, and let's run that. All right, so now, in addition to the histogram, we have the summary data at the bottom. And I'm gonna choose a small number here. So I now have 5 values that are creating this histogram, you can see. And I also have 5 values creating this, this summary data, the summary function value output. And so I want you guys to play with this and tell me what is kind of off about this app the way it is right now. What's something that it's doing that a user might not catch, but is probably not desirable behavior. So use the running app to kind of experiment with it. Maybe look at what's actually going on in the code here, and tell me what seems kind of messed up. give you a minute to play with that. Anyone feel like they already kind of see what's not so good about this app? Yeah.
Scale changes.
The scale changes? That doesn't bother me so much, but okay, sure, yeah, okay, yeah.
Draws a different sample.
That's the one I was looking for. Yeah, the scale change thing can be annoying. It doesn't, I guess partly because this is just kind of toy data, it doesn't bother me now, but the big one I was looking for is that when you, and you can sometimes see it, it's maybe easier to see with smaller data. But like in this example, right, the maximum value in the histogram is 1.4. The maximum value in the summary is 1.56, right? These aren't drawing from the same data. And most likely we want them to, right? And you can see in the code why this is happening, right? Because I take one sample of input $num values here, and I take another one here. And these two samples are not linked at all. Yeah?
How do you know you're taking another one?
Because I'm just calling the code 2 different times. And so if I'm not saving it, as anything and using it twice, it's just going to call the code twice. It's not going to know that they should be the same. Yeah. So let's try to fix that. Close the app. Okay. So they're pointing out now, right? It's these 2 different calls to random normal, right? They're updating this one change is updating 2 separate blocks of code, and they're not linked. All right, so what we'd like to have is that when we update the slider, we have one value here, one data set from the sample, and that gets used by both of these code chunks. So we're going to do that with the reactive function. So we're going to have output, we'll just call it our data. And we're going to, instead of having 2 calls to our norm, we're going to have one that we're going to wrap in a code chunk here that's evaluated by the reactive function. And we're going to store that output as something called data. So that all seems pretty standard so far. There's one little catch, which is that data, you can think of it as more of a function than a value, or you can think of it as both. But when we want to call what's in data, we're going to call it with empty brackets like it's a function. We'll still get out the same value, the same way that if you normally in R created a variable called data, the output is going to be the same as that, but we have to call it with empty brackets like it's a function. So from our app before, where we had these 2 calls, we'll now add, see if I can, we'll now add this new thing, data, which is the output of the reactive function, where the input is taking a random sample. And we're going to replace these 2 with now data in here. And like I said, the main difference between normal R behavior is that data will have these empty brackets after it because it's reactive. All right, so I want you guys to go in and actually make this change on this 2 outputs app just to kind of get experience with it and see if you can get it to run so that now the histogram and the summary actually agree with each other. I will show you this so you don't have to remember it. Yeah.
If you were to create, if data were a data frame, you want to get like a specific comment from it, would you do like data parentheses, and can you still use function operators?
So yeah, you'd have like data, open parentheses, $, right? So it's really just like, you can think of it as like a character the same way as a variable, just a variable that's its name. You can think of it as a variable whose name ends with open parentheses, although it's not, it is a function, but. While you're doing that, I'll show you some not ideal behavior, right? So let's see what happens if I do this. Nope, didn't like that. So what this was is if you just kind of jumped right into Shiny, right, and you kind of cut and paste some code from somewhere, or look at some help pages, right, you probably would think to yourself, well, I just need to create an object called data based on the input, and then I'll feed that to my 2 histograms, right? But data, if I create it this way, it's no longer reactive, right? The reactivity chain is broken, and that's why my app does not work. But if I've actually done my homework and done some reading on how Shiny works, I know that I have to wrap this in a reactive function. It doesn't have to be reactive, but that's what we're using. And call data with open parentheses. And now, fingers crossed, this should work. I might need to get out of here. Still running my broken app. But where? Why? Just need to unbreak my console for a second. Why am I not? It's weird. It's like it's running, but I don't see a stop.
It must be hidden off to the right.
I think, yeah. There we go. Good call. Okay. And now let's run this. Okay, so now it should work. Now this data I see in the histogram looks like it actually corresponds to what's in the summary. Still looks a little strange, but it does now correspond. Okay. So let's go back here. So now we've seen again how to continue the reactive chain, but have this intermediate step so that we can use one reactive object in both of our future calls that create our output. And this is sort of just a diagram of it, right? I update input, data updates once, and we run all that code. Right, and we saw that if I don't, you call a reactive expression like a function, right, with these open parentheses. So there's no arguments in the function, but you call it like a function. And that's key. If we don't do that, reactivity breaks or just doesn't know what this thing is. And so reactive expressions will cache their values. So data, open parentheses, will maintain its most recent draw of the random normal distribution until input updates again. Okay. All right. So going back to that app we had, where every time I made one little change in the title, the whole plot updated. That was annoying, right? So we can turn that off. We're going to do that with the isolate function, right? So again, we don't want it to update every single time. We change the title, but that's the default behavior. But if we take some code and we wrap it in isolate, it's no longer, we basically turned off reactivity, okay? So from this app that we had, the 01 to inputs, we can then isolate. So let's all do that. Let's open 01 to inputs. It should already be open. Right, and let's take main and we'll isolate what's in it. Whole expression. Good, good. Okay. And let's see what it actually does. All right, so I'm going to try to change this again. So good. So now when I'm typing, this thing is not updating, right? But if I update the slider, not only does the plot update, but it takes my most recent title. So that seems a lot more desirable for a user, right? I probably only want the plot to update when I actually change the data. But when it does update, it'd be nice if it used the title that I actually have sitting there, right? And so all we did was we changed it so that the title called a value that was isolated. So every time I update the slider, because this is reactive code, it all runs again, right? But because the input title is inside isolate, updates to the title input don't cause this whole thing to rerun.
Can you have a button?
You sure can. We'll get to that. Yeah. Right. Right. So yeah, sort of what he's getting at is in this case, it's kind of nice how the plot updates. It seems to work, but maybe I want to actually expose to the user when things are going to update, right? So we'll see that too. So visualizing what I was just explaining, right? I no longer have a reactive chain from the input title argument into this code that runs. It's only reactive to the slider input. But still, when this code gets called, it will use the most recent value of both of these inputs. Okay. So what if I only want certain code to run when I actually do something like click a button, right? So another input we can have is an action button, right? We've looked at sliders and text. So now we'll look at action buttons, which is, like it says, a button that does actions or responds to actions, right? So similar to a slider, we have an input ID, so we're calling it go, and that means that it will enter the input list as input $go, and a label that the user actually sees. In this case, it's click me, and it will just appear on the button. All right, so let's open the little app with an action button in it. It's 05. And we'll run it. First, I need to stop the last app I had running. And then I need to run. Okay, so all it is a blank page with a click me button. And when I press click me, it seems like nothing happens, right? Let's look at the code. The code says that I have this, this action button called click me. And the server function says, it looks like it's saying that when input clicks, something happens with input clicks, the code that gets evaluated is print as.numeric input clicks. So it seems like something should be printing, although we haven't totally explained what this observe event function does yet. It does seem like it should be printing something. Does anyone see where it's printing? Where is it printing? In the console, yeah, right. So it is printing. What it actually is printing is the number of times I've clicked this thing, and it's printing it to the console. Right, so notice that observe event doesn't get sent to some item in the output list. It's not like output $ event observed equals this stuff. It's just lives here, right? And also notice that the default place for things, if I just say print, it's just gonna print on the computer that's running R that's powering it. Sure. I haven't sent it to the output in any way, right? So that seems like a reasonable place to print. Also notice that the click me, it's just the value that's associated with it. Unlike, say, a slider where it's pretty intuitive that the value that's associated with it is just the number that the slider is on. It's not obvious what value would be associated with the click me button, but we can see here that the value is just the number of times I've clicked it, which is nice because that means that every time I click it, the value has changed so things can update and know that they're out of date. Generally, you don't really care what this number is. And here, we just wanted to show it, but yeah, that's sort of how that works. So now we can go back and kind of see more what this is doing, right? It's saying when I actually, in response to the input clicks, this argument which changes every time I click the button, I want to run this code, which now I can see is printing out as the numeric version of the input clicks output. Okay, so that's how this works. Let's actually maybe use this in a more meaningful way. So I stop that app, go back to the slides, right? So again, just to walk through that observe event function, right? This first argument are the reactive values that it will actually respond to. So in this case, the input clicks. And then the second argument is the code that gets run. But this code, so it says note, observer treats this code as if it had been isolated with isolate, right? So what that means is that if you could imagine that these were two different inputs, this input would no longer be part of the reactive chain. So if I updated this input, it wouldn't cause this whole thing to rerun. Only when I update this input in the first argument is it going to rerun. And again, notice that I don't send this output anywhere, right? So there's also this, I'm just going to mention this observe function. It only has one argument, right? So it doesn't have first reactive values that it responds to. It just has this block of code to run. And it will respond to every reactive value in the code. So now it's just going to it's going to update to anything that's in here. So it's sort of like a less controllable version of observe event. So you'll probably find yourself using observe event more. Observe event exposes more to the user or the programmer, which are the reactive values and which are the isolated values. But observe also exists. Okay. So I lied slightly. We're not actually going to use observe event in a meaningful way right now. But we will use the next one, the next reactivity toolbox function, event reactive, in a more meaningful way. So event reactive is going to look very similar to observe event. So we're going to look at a similar app to before, right? And we're going to have now an action button called, to the user update internally called go, right? Which is going to control the relationship between the input here and the output here. Okay. So what this event reactive function does. So like I said, it looks extremely similar to what we just saw, right? The first argument is reactive values that it's going to respond to. The second argument is code that is isolated, right? So it doesn't update anytime some of these inputs are changed, right? Because they're isolated. The big difference is that now notice I'm actually pointing to some output. So this function actually creates output that I can store and then can be brought back into my display, into my output list.
So for you have been using base R as functions and stuff.
Yeah.
Can you use packages?
Absolutely, you can use whatever packages you want, right? You'll just have to load them the same way you load Shiny here. Load ggplot, and then you can use ggplot functions. Yeah. Okay. So this, actually, it's in the code. Maybe let's open that one, 07 reactive. Event reactive. Okay. So this app looks very similar to what we saw before, but it has this action button now, right? So now I mess with the slider, nothing happens. When I press update, something actually happens. Again, I can like play with this all I want. It will only update when I press update, okay? So input, in terms of our UI, right, it's pretty much, we just switched out a text input with an action button, but it's pretty much what we've already seen. What's key now is what's happening in the server function. So we still have server as always, a function of input, output. But now we take event reactive. We tell it, okay, I want you to be reactive to input $go, which we specified as this action button. And I want you to use but not respond to what's in this curly bracket code chunk. So that's input $num, or the value of the slider. So again, it will use the most recent version of that, but it won't be reactive to it. And so what you'll create is, just like we saw before, a reactive value called data, which means that later when I want to use data, it has to be data open parentheses, not just the word data. And that, because it's reactive, can be the input to my histogram, which is then sent to be a plot. So that's everything that's actually happening here, right? Click this button, it responds to this value of the slider and creates a histogram here using reactive output, which it then displays using render plot, and then sending the output of the plot into here. Okay. All right, so this is just sort of walking through how they created all that. Right, again, data, open parentheses, because data is reactive. And so what this looks like is I have two inputs, but we're only reactive to one, the one from the action button. I click it, it calls both of them and updates. Okay. Any questions? Okay. Okay, so one last, I believe this is the last reactivity function is just, it's just called reactive. So, or sorry, reactive values. When I changed the slider, right, it changed the value of the input $num, and those were all reactive values and part of this reactivity chain. But what if I want to create reactive values that don't come from the input? For that, I use this reactive values function. And so I'm going to store the output of this reactive values function as RV. And what it will be is Again, random normal draws 100 of them. And so let's see how that actually gets structured. I take reactive values, I save it to RV, and then this thing data is added to a list called RV. So I just call it with RV This is where if we were like on TV, like a dancing cat or something would come. Now I do this. Okay, so looking into actual how these two functions are structured, the observe event and event reactive. The first argument is the same, right? Event expression, and that is what it says, expression that represents the event. That's not particularly explanatory. But basically it's your reactive inputs, right? And that's the same for both of these, observe event and event reactive. But the second argument for observe event is called handler expression or handler X. And for event reactive, it's value expression. So observe event, this is what I just want to be clear what I mean by like a side effect. So observe event second argument is handler expression. This should be a side effect producing action. The return value will be ignored. So right, it's updating. We saw like it could update the value of RV, $, whatever, right? It's updating items that existed in that server function. They could also update things that are outside the server function. But again, no output is created. Versus event reactive second argument is the value expression. So it's actually what's going to be returned. So this is just a little detour from this diagram. Right, explaining why observe event and observe kind of come off of the input, right? And don't, unlike event reactive or reactive, don't send something into this output list. Right, and then we saw we could create our own reactive values, right? They don't have to come from the input, which can also get put into our output list. And from the output list, right, we're going to have render functions that actually turn that output stuff into visualization. And we can also isolate things that come in from input using the isolate function, right? So that expressions that would normally be reactive to them are no longer. Okay. Last tip from this section, right? When you actually publish a Shiny app, right, you're going to have different instances of the app, workers, right? So like servers, and then end users actually connecting with your app. And what's important about that is that where you put different parts of your code affects how many times they're run and then how computationally intensive your app is, right? So what this is saying is you can put code outside the server function anywhere, and it will only be run once per section. So that includes like, you know, library Shiny. That's going to get run when this file essentially gets opened and run one time. So you could even put up here, you could load in certain data, right? You'd want it to be stored in a, you know, relative or access relative to where this app lives, right? So you want to make sure it's actually knows where to look, but you can load in data, you can make subsets, you can do whatever you want before this actual UI and server code starts running. And that'll just happen one time. Right, code inside the server function will be run once per end user or connection, right? So, so we've seen how that will update per call. And then code inside a reactive function will be run once per reaction, right? So every time I click or whatever it is, right? So it's not, I don't have to rerun the entire server function every time, say, someone clicks a button. So if you don't need your code to get rerun every time someone clicks a button, you don't want to put it into a reactive expression, or not into that reactive expression. Okay, so that concludes the section. So it's a good time to take a break. We're actually a little ahead of where I thought we'd be, but after the break, we'll talk about customizing the appearance of the app. I'll show a little example with Plotly for those who were, very small example with Plotly for those who were here a couple weeks ago, and we'll talk about how to share the apps. And if you have any questions during the break, please ask. I'll take the mic off. All right, welcome back. All right, so like I said, we sort of talked about overview and reactivity. Now we're going to talk about customizing the appearance of your app so they don't just have to look like a white page with some buttons on them. But first, I mentioned I sort of skipped how to share this stuff. So I want to do that first because it's important. I want to make sure we talk about it. And then we can go on to customization. Okay. So sharing your app. So like I said, every app is maintained by some computer, whether it's your own computer or a server, right? So this is, I think this is actually maybe slightly out of date and it's not so stringent at this point, but we'll still go over this as kind of like a best practice of how to save and structure your app. So we've actually mostly seen apps like this one, right? Everything is in one file. I have a UI, a function, a server function, and then I run Shiny app. Another example, let's see. Another example is this just app.r. Slightly more complex, right? But I still have, here I have some, like I said, you can have just external code that just gets run once. Here they run palette. Load Shiny, and again, I have the UI function, the server function, a little more stuff in it now, and then Shiny app at the bottom. But this one is stored in the kind of best practice, standard way of you put the app in a file called app.r. That's what I'm getting at. You can also put each of these, they show an example, you can put the UI function and the server function in their own files. So you'd have a UI.r and a server.r that contain each of those functions. And then they would still be called by your app. And so the structure would be, you have a folder, app1 or whatever it's called, that contains those two files versus, that they showed here, versus before you had your folder app and then you just had the app file. So this is like kind of the simplest way you can have your app, but you can have other stuff in that folder as well. Where did that go? Sorry. So I guess it didn't show, but yeah, you can have other stuff in this folder as well. You can have data sets, images, other stuff that gets called and loaded. And actually, that's in the code example too. But I'm not sure. It says you must use this exact name, app.r. If you're just running stuff locally, as we've seen, you can call your app file anything you want to. When it gets run by like the RStudio server, I'm not actually sure if that restriction is still mandatory, but I guess it never hurts to just call it app.r, then you can't go wrong. But okay, so suppose you've created a folder, you put something in it called app.r or ui.r and server.r. So now you want to share it, right? So one way is, let's go actually to here. Okay. One way, suppose I want to share this publicly. And when I say publicly, I mean anyone can, if they have the address, access it. An easy way to do that is to create an account at this website, shinyapps.io. I've already done this. It's pretty easy. Assuming you've already done it, so I think we'll have some time at the end if you want to do this and play around with it, but I'm not going to make you do it right now. Assuming you've already done it, you go into, from RStudio, you can go into Preferences and Publishing and Connect. And then if I click here, I'll be able to connect the account that I've already made, and it will walk you through how to do that. So you'll get, from your login on that account, you'll get a token and you'll put it here. Just follow the steps. but that's one way to do it. It's totally free, and you get, I think it's 25 active hours. Close. Why? Why won't you let me close this window? It will neither let me shrink nor close. Let's see. No. It said it's easy. I said this is easy, but I didn't anticipate this kind of thing. Anyone have any suggestions of how to close this window?
Maybe put on view.
Yeah.
Or tools and
Move focus to console? No. Oh, there it is. Nope, still gone. Why? Yeah, okay, let's try that. There we go. I was too zoomed in. Thank you. Okay. Anyway, that's how you link. So once you have your stuff stored in a folder in the way that they want it stored, you link an account with you link your shinyapps.io account, and it's pretty easy to just publish it on their server. And like I said, I think I wrote it down. I guess I didn't write down the number. I think it's 25 active user hours per month you get free, and you get a certain number of apps you can have running at a given time, right? And then you can pay to increase that usage. So if you actually have an app that you think is going to be used by a lot of people, you could do it that way and pay for it. So that's assuming that you want to share what you're doing publicly, right? Suppose you either don't want to go through the hassle, or you don't want to, or you can't share your app publicly, which that's a case we've run into. But suppose the people that you're sharing this with have no R knowledge, right? Another way to share it, which I've also used recently, is you could actually launch an app from the command line. So it's just this simple code. I'll make it bigger. And actually now you can do stuff in the command line from RStudio if you just want to never leave your RStudio window, right? So there's next to the console, there's this terminal window, and I can type in terminal commands there. So let me, actually this needs to change. Okay, so let me just show you what this looks like. So I've been showing you these kind of basic apps that they gave us. So I'm gonna run one of those apps from the terminal, but it's just R-E shiny. So this is now basically, the next stuff I'm giving it is basically R code, but now it knows, the terminal will know to evaluate it like R code. And then I'm gonna give it the path to shiny code to app.r. So the path to where I've stored that app, and I'm going to put that in single quotes so it doesn't interfere with my double quotes, and run. Okay, so now I see this, right? So I think my app is running, but I actually don't see anything. So it is running locally. So if I just take this address and throw it into a browser, I see it, right? So if you wanted to share this with a colleague, they'd have to have R installed, right, to actually run this thing. But they don't really need to know any R or, you know, have ever opened RStudio for them to get it to work. So it's kind of an in-between option for sharing. Obviously, you can just share your code with someone if they know R and they can run it. But this is assuming your collaborators don't want to do that. So that's a useful thing. And again, that keeps everything private. A third way, which we're not going to talk about, is you can actually like create your own server. Then you don't have to pay for it, but you still have to pay for the server space. So it depends on how much that costs and whether it's actually worth it. But you're not wedded to like the RStudio server world. You can do it on your own, and they actually have tools for doing that. I've never actually done it personally, so not exactly sure how it works, but it's there. So that's in their little summary. right? So we talked about using a shinyapps.io account. They have another getting started guide for the specific way of publishing. Yeah, and so they just mentioned, there's more slides in the original that I took out because I didn't want to go down that road, but you can build your own server with Shiny Server, Shiny Server Pro, if you want something, again, like scalable and not necessarily paying for it through RStudio. Okay, any questions about sharing? Okay. So, all right, so back to building apps.
I guess I do.
Yeah.
I don't know. Do you happen to know like if there's limits to the like processor speed or like number of cores or that run on the server? Computations.
I don't know. I don't know how they calculate active hours. There's probably a data limit, but honestly, you're more likely to hit limits with the app itself getting slow, unless you design it, with this specifically in mind. You're more likely to hit limits with the app itself. If you have huge data with the app itself getting slow before you actually hit that limit. At least I've run into an app just getting too slow to be useful before I've actually run into storage limits. Yeah. People are now designing things to make it faster, but historically that's been a limitation. Okay. Making it pretty, part 3. So this is what I wanted to show before. The example I had before didn't quite work, but this one will work. So if I type in fluid page, and actually it's already in my code here. Up in the beginning. Okay, so if I type in fluid page, let me stop this app first. Okay. All right, so if I type in fluid page, so we've seen, I didn't really focus on it, but we saw in the apps that we had, so I'll just give an example. In the UI function, it was fluid page of all this stuff, right? So that basically sets up the page that everything is going to go into, right? And we can, if it's empty, like we saw in the first app, or before we added Hello World, right? I'll just have an empty page. So if I type actually fluid page of some text or even empty into my console, what comes out is HTML, right? So that's what's actually getting spit out from fluid page, right? And it was the same, we saw it with the input button, right? You saw, they showed what the argument looks like to you, like slider input or input slider input of all this stuff, and they showed what that HTML actually was. So when you're putting in nice and meaningful things in your app, like, your slider input and your plot or whatever, focus on the input for now. So you're putting your slider input, what's actually getting added is chunks of HTML. All right, so yeah, so I actually did have it back over here, right? You can actually see, right, slider input is this chunk, plot output is this chunk. But thankfully, you don't have to always be exposed to that. All right. So we saw the just fluid page with nothing in it. Looks just like this div class fluid container, right? So it adjusts to the size of your window, but nothing's actually inside it, right? So that would appear like this, an empty page. So I can start adding HTML to a web page, right? Who here has used HTML before? Some of you? Oh, most of you. Okay, so you've seen this before. This probably looks actually more comfortable to you than to me. I try to avoid writing HTML whenever I can. So right, but I can add a header tag, right? And then it will be this big bold text. I can add a paragraph, right? Now we have smaller text, that's just the paragraph style. I can add a link, right? So now I'm saying with the A tag, this will be my link, and then this will be the text that appears for a user. All right, so I'm just basically writing a web page. Right, and you add content to a web page with these different tags. So in R, you don't have to call those tags directly, although you can. You can use in this tags, these tags. So tags is like basically a list of functions. So like tags $H1 is a header function. Tags $A is that hyperlink. And so these functions are part of Shiny, right? Tags that all in this tags list. And there's a lot of them, right? So if I look at all the possible things in tags, it covers a lot of ground. Buttons, captions, etc., different headers. And you can actually see what those functions do, right? So the output and the text of the function, right? They follow a certain syntax, right? So you want the tags list, I want the A function from it, and then I need to give it certain arguments. So for A, which is the hyperlink, I'll give it the actual link, and then what the user sees. Right, so if I want to do bold text, so it's just a bunch of examples, right? I can do bold text, and I can put that directly into Fluid Page. Because again, Fluid Page is basically just assembling HTML. So I can put in HTML directly, which we'll see, and I can put in the output from a tags function, which creates HTML. So now I'm just creating bold text. This is a useful one, the break function, right? If I want to just create one line of space between some input and some next input, I can just use HTML for a break. Or I can put in an image, which is again useful. I can specify image height and width, and then I can specify a URL that it comes from. Or I can, so I wanted to show before, but actually had the wrong spot. But so I showed before like a basic app directory with your app.r, but you can put in a subdirectory called www. You can put in a bunch of image files. And then it will actually know from tags image that if I say that this src or source is this thing, it will know that lives here in www, or it will at least look there.
Did you have to tell it that somewhere? Or?
No, so it will, if I put it in that www folder and then I put nothing here, it will look there. And actually, sometimes you don't even, not every single one of those tags, but sometimes there's actually a standalone function, so I don't even need to do tags $H1, I can just do H1. And there's a list of some of those. Just makes your code, I guess, a little cleaner. So again, I can write a web page in HTML, and I can switch out, just so you can see, right? I can switch out HTML for the H1 function, which also produces HTML as its output, right? If I'm doing this in R with Shiny, the output is the same. Another thing I can do is I can just wrap this whole thing. See, this disappear. Okay, I can wrap this whole thing in this HTML function and supply that to Fluid Page. So if you already have a website you wrote in HTML, you can just throw that in as well. Just wrap it in HTML. Right, so this is a simpler example of just putting in that raw HTML. And then they have a whole article about how to add all this different HTML into a Shiny app. Okay, but that's sort of like what you should keep in mind as you're building up these different pieces is that they're actually just adding HTML chunks into a web page created by Fluid Page or by some other kind of page. All right, so we've kind of just been putting things in our web pages, and they just go in as, you know, sequential rows, or sometimes they'll get placed next to each other. But most of the apps that I showed you, especially the more complicated ones, actually have some kind of structured layout that makes it a lot nicer for the user. So there's a few different kind of basic ways to do that, right? So the layout, the basic idea of a layout is as a grid on your page. And then you can also have layers of pages. So we saw a fluid page as our kind of outermost containing argument. Inside that, we can put in fluid rows, right, which will also adapt to the size of our window. And we can put columns within rows. Again, we're still just building up HTML code. So an example, right, is if I can have within fluid page 2 different fluid rows, and they'll just get placed one after the other, and they'll take up the entire available width. Then within each row, I can split up different columns. So what this does, I have column 3 and column 5, and that's specifying out of 12, that's just what it is, a total space of 12, how much of the space to take up. So the first column will take up 3 units, the second column will take up 5 units, and then this column's a little bit different because I offset it by 8, so it doesn't start until the 8th unit, and then it has a width of 4. Right? If I didn't specify these values, it'll just take up the whole thing. Right? So again, I'm just like building up a grid of things on the page. And again, you can see what that looks like as HTML, although I actually don't, when I looked in the back, I don't think you can actually see this light gray text, but it's some HTML. Okay. And I can even just put in text in the row. I don't have to put in column arguments or anything fancy. And that's what it will do. Right? But I can put in fancy stuff, right? I can, in my column of width 2, I could put a plot output, for example. Right, so just getting a little more complicated. I can see what an output with a bunch of rows and columns would actually look like. And then as I add stuff to it, right, I'm putting my slider in the second column, his output down there. This is what it would actually look like on the page. Just as an example, not exactly desirable. All right, so recap is that from a basic layout, you think of your page as a grid, give it rows and columns to work with, and specify column widths as desired. All right, so in like that water example, right? Actually, a couple of the examples that we saw, right? You can see we have different tabs on the page, which kind of makes it look like more like a website. Okay. Right, so in that water app example, right, we had this kind of main page with different headers and the tabs on it. Right, so building up to that, we can, you probably see this a lot actually on Shiny apps, right, is this kind of format. It's a little bit light, so you can't totally see it right now, but I can just wrap what I had before as like slider input and text input in a well panel, and that just kind of visually separates that I want these 2 input fields to have this gray background so that the user can see, okay, here's the input versus where the output is. So again, it's just wrapping it in a well panel. And then there's all these different kinds of panels. So this is on a given page, right? Tabs, fixed, etc. You can use this as necessary. I won't go through all of them. But one nice one that you are likely to use is a tab panel, creating like tabs, right? Stackable layers. And each tab is like its own little page, basically. Right, so we'll see how this gets fed into a larger thing in a second, right? But so I'll have my tab panel, I'll give it a title for navigation, right? That will appear, and then whatever I want to put inside it. So what does that look like? Come back to that, right? Right, so I have within my fluid page, looks bigger, the tab set panel, and then I have within that, tab panel, tab 1, tab 2, tab 3. So you can see these titles are my tab labels. And then I didn't put anything in. I just, for now, it's just text contents, right? But you could put in plot output, histogram stuff, whatever you want to put in there. Okay. Okay. So let's actually just play around with this code a little bit. Go back into the code, and now we're in part 3. So code part 3, and then the tabs. 05 tabs. Open that up. Let's actually play with this code and make it so you can actually see it. It's a little hard to see up here. Okay, so this is another app called Tabs. I load Shiny, and then in my UI, right, I still have my fluid page with the title, but now I have a tab set panel, and then 3 tab panels within that. And each one's going to have a title, some plot output, and a button. And that's all. You can look through. That's all created in the server function, but let's run this. So that's what it would look like, right? Normal data, uniform data, chi-square data, each on its own page. And then the button, which you couldn't see before, to redraw it anytime. All right. So as your apps get more complicated, right, you're probably going to want to separate them out into their own little tabs or pages. And just, you know, architecturally, it looks like this. Another way to do it is the nav list panel. So this is just stylistic, but if you would rather have your tab labels on the side there, and then a new page comes up every time you click, it's very similar, right? I still have tab panels that come up, but I wrap them in a nav list panel, and the output looks like that. All right, so that was all building layouts from scratch. Any questions so far about layouts? It's all pretty straightforward, at least conceptually, right? Knowing actually which function to use can be difficult. But conceptually, we're looking at a grid, right? You can also help yourself out with a prepackaged layout. So I can take, within Fluid Page, I can have a sidebar layout, which will say I want a sidebar panel with some stuff in it and a main panel with some stuff in it. So if I actually look at sidebar layout, right, you can see it has 2 arguments of stuff, right? The sidebar panel, I'll give it, and the main panel, and then I can tell it position and a couple other things. And there's an example with that in your code folder. I'm not going to focus too much on fixed page, but you can have a fixed page size. I've never had a reason to use it, but I'm sure there are good reasons, depending on, you know, browser compatibility and things like that. I just haven't needed it. And then finally, another kind of page layout, but I'll leave that for you guys to play around with. Again, so if you go into code in part 3, there's all these different kinds. You can see examples of all these different kind of sidebar, navbar, different kinds of pages, right? It's kind of helpful to have them there if you are building one later on. You can see a very basic example and what it looks like, and then, you know, adjust for your personal use. But don't open in Xcode. Okay. All right, so again, prepackaged layouts can give you kind of nice breakdown of the page without you having to specify, you know, this row, this column every single time. And the same thing with tabs. I didn't talk about Shiny Dashboard. It's another package you can use to create layouts that look more like kind of Tableau dashboards. And actually, I think this app, one of riches. I think this probably used that, and his code I'm sure is available if you want to check it out. Please wait. Okay, I'm pretty sure this, so you get this kind of familiar looking navigator, sidebar, etc. This would be more like the visual flavor of something you make with Shiny Dashboard. Looks pretty good. Okay. All right, and then the last piece to customization is CSS. So here's used CSS before. Okay, yeah. I mean, I've like sometimes I'll add a pre-made CSS file to something so that that will dictate some style elements. I don't generally write much of it. I just haven't needed to. But basically, CSS can add style to these elements in a few different ways. So cascading style sheets, for those who are wondering what it stands for. Right, so you can add a folder to whatever .css that will give you kind of like global defaults for style on the page, right? You can change things individually for like one app, which we'll see, or you can actually change individual elements. So there's sort of like, you know, if I write individual CSS to a tag style attribute, it's just going to change that one thing, right? Versus changing a whole file or a whole section or the whole document. And the lowest level, this will override a global setting and override a more global setting. So what does that actually mean? In that www folder I mentioned earlier, you can add a CSS file, which you will most likely not write yourself, but will have pre-made settings. So we can actually look at what that would look like here. Sure, let's open it with RStudio. Oh, that's a different folder. Sorry, let's open it with text edit. All right, so that's not so pretty. Maybe just to see what the CSS actually looks like and sort of is doing. All right, it's sort of a little easier to read, right? But it's basically just a bunch of things that set how different elements appear. That's probably not readable to you, but that's okay. It's in your folder. All right, so I can do that. I can add a folder, a CSS folder to my app directory that will then get used. I can also put that into Fluid Page as a theme argument. Or using a tag, right, for a link to a style sheet. The first way is, I think, the easiest, but there's different ways, right? So the second option was I can change things globally, right? So I can say that the style of this certain element always has the color red. Or lastly, most specifically, I could actually go in and say, now I want the header to have style color red. So this is like in CSS format. So it's just good to know that that's there and that's an option. I'm not an expert in CSS, but you can read more about it in one of their articles. It goes into more detail. It's also something, you know, it's pretty much personal. What of that you'll actually want to use at any given point, right? Where customization so far in R has failed you, you might need to actually dig into changing the CSS. All right. So that's actually all I wanted to cover. It went a lot quicker than I was expecting. Oh, actually, one more thing for one more Plotly thing I'll show you. But we covered a lot of ground, right? The overview of the architecture, the layouts, and a little bit less, but some discussion of how to customize with CSS and also HTML. So you should actually be able to code up a basic app at this point. We already did some really basic ones. But again, like I started writing Shiny apps before I actually read up on how they work. And it was very frustrating, constantly Googling everything and not knowing why something was breaking. So even though this is sort of like a more, you know, nuts and bolts kind of way to approach it, it is really valuable when you then see an error that says, like your object is not reactive and it's causing this error. Now you actually can know what that means, and it's a lot easier to debug these apps. So right, last thing I want to show, which sorry for people who weren't here a couple weeks ago, which is probably most of you, but I'll keep it quick. Really, really short, this short app using Plotly. So 2 weeks ago, I covered interactive graphics in R, but I focused on Plotly partly because of its compatibility with other interactive graphing packages. And actually, I didn't really go into this at all because we hadn't talked about Shiny yet, but its compatibility with Shiny is really nice. So Plotly will basically, you can take a regular ggplot. Just make sure I have it loaded. You can take a regular ggplot that you've made and you can basically make it interactive with Plotly. So let's show a quick example of how this works. Let's say that we have this plot here. Just a basic histogram in ggplot. It looks like this, but I don't know what the data is actually referring to. If I then wrap that in Plotly, ggplotly. It looks exactly the same, but now if I hover over stuff, I actually see the data that's underlying it. All right, so it basically makes an interactive plot that exposes the data and other elements, and I can get more into that, but that was the 2 weeks ago workshop. But I can also throw that into Shiny very easily, right? So this is a very basic and kind of like not best practice app that I just wrote to show this specific thing. But so I actually kind of defined my UI and my server functions on the fly. So within Shiny app, which is that's generally been the last thing that we've called, right? I call Shiny app once I've already defined UI and server. Like I said, this is kind of just a hacky example, but so I'm actually going to create my UI right here. I'm just going to create a fluid page of, instead of plot output that we've seen before, now I just have Plotly output of this thing called plot, right? Which we now know that means I must have added some element to my output list called plot, or else this wouldn't do anything. And I did, right? So here, again, creating the server function just on the fly and feeding it in. It's still a function of input and output. The output of this stuff, I'm going to store in the output list under the name plot. And what this output is from the Plotly package. I'm going to use render Plotly. So just very similar to before, render plot. Now it's just render Plotly of this ggplot. So I don't even actually need to wrap it in ggplotly, right? I can just wrap this ggplot function, just a simple thing with built-in data, in render Plotly. So it's a reactive and interactive plot. And so let's actually just see what that does. All right, it looks very similar to the plot you just saw, right? It just exists on this fluid page, but now when I hover over stuff, it will show me the data. So if you were imagining building apps with different ggplots, right, very easy to just, if it's necessary, switch them out with interactive plots. And it's also nice because, so you're now in this Shiny world, right? Which means that you have the power of both interactive plotting through Plotly and other packages, and you have the power of Shiny, which can do dynamic actions on the server for you. Like, you know, I can subset the data and it can call different models on the fly, right? That stuff I wouldn't be able to do with just interactive plotting. It's too many different options. It would be too much stuff for me to just send all to the browser. I need to have that OpenR connection. But there are other things, like say I just want to have, you know, this kind of interactivity, or I want to put in a range slider. We saw that a couple weeks ago. So just control the X limits of a plot, stuff like that, where I don't actually need to be updating my calculations. I just need to be updating the visualization, right? I can do all that still in the same Plotly framework that I'm used to, and just throw the output into render Plotly, and it will show up on my app. So I just wanted to mention that. And I think that's it. So we'll end a little early, and I'll be around for questions if anyone has any. Feel free, if you were one of the people who raised your hand to having a specific body of data that you wanted to make a Shiny app out of, feel free to stick around here and start that and ask questions with all this fresh in your mind. But otherwise, have a great weekend.